Exercise 7.2 Problem 10 Discussion. Let's read the problem. A student sitting in a classroom sees a picture on the blackboard at a height of 1.5 meters from the horizontal level of sight. The angle of elevation of the picture is 30 degrees. As the picture is not clear to him, he moves straight towards the blackboard and sees the picture at an angle of elevation 45 degrees. Find the distance moved by the student. Okay, so a student is sitting in a classroom and is seeing a picture on the blackboard which is at a height of 1.5 meters, right, from the horizontal level of the sight. The angle of elevation is 30 degrees. He is looking up, so it is angle of elevation. As he is not able to see it clear, he moves towards the blackboard, and whenever you get closer, the angle of elevation will increase and it becomes 45 degrees. So we are asked to find the distance moved by the student. Okay, so let's draw a simple diagram. So here CD is a blackboard and D is the picture on the blackboard which is at a height of 1.5 meters from the ground level, and the ground level is taken as the level of sight. Okay, the eye level basically. Okay, so the student was originally at position A and is seeing at the picture and the angle of elevation. So this is the eye level and this is the line of vision actually. Sorry, this is the line. Okay, so this is the angle of elevation 30 degrees. Okay, now when it comes to this point, he was not able to see, and here he moves closer to point B and he is able to see the picture, but as he moves closer, the angle of elevation will increase and it becomes 45 degrees. Now we are asked to calculate the distance moved by the student from the initial to final, that is AB is the distance here where he has moved, and that is what we need to find. Now we know this side, that is 1.5 meters, and we are given these angles and we have to find this horizontal distance, right? So what is the relationship which we can use? Think about this is a known, this is unknown, and this is an angle. It is tan theta. Tan theta is opposite by hypotenuse. So if you use tan 30 in this bigger triangle, that is in the triangle ACD, you will be able to get this distance AC, which is the adjacent side for tan 30. Then you come for the smaller triangle BCD, use tan 45, you will get the smaller distance, that is BC. So from the first we find AC, from the next triangle we find BC, from these two we will be able to find this measurement. Okay, so this is how this problem needs to be solved. Let's list out. Height of the picture is 1.5 meter, angle of elevation is 30 degrees and 45 degrees. Okay, we need to calculate the distance moved by the student. Okay, and as I was explaining, it is a tan theta which needs to be used in this problem, and tan theta is opposite by adjacent. So let's go into the step. First step, as usual, we need to draw a rough diagram, label and mark the diagram with the given values. So that's what we did. So this is the blackboard. This is the first position of the student where the angle of elevation is 30 degrees. He moves closer to the blackboard and the angle of elevation becomes 45 degrees, and the height of the picture is 1.5 meters. Okay, now next, in the triangle ACD, okay, substitute theta equal to 30 degrees and find tan theta, and tan theta is opposite by adjacent. Adjacent here is side AC. Okay, so you need to substitute the value of theta, which is 30 degrees. Height of the picture is 1.5 meters. In the formula, tan theta, that is tan 30, equal to opposite by adjacent. Opposite is what? CD, that is 1.5 meters, and adjacent is AC. So here this is known and CD is known. Okay, and this is the only thing which is unknown. So you will be able to calculate AC from this relationship. So we will be able to calculate the total distance. Next, take this smaller triangle BCD, go by the same relationship. So tan 45 will be 1.5 divided by BC. Okay, so tan theta, where theta is 45, opposite by adjacent, that is CD by BC. And from this relationship, we know tan 45, we know CD is 1.5, and this will be calculated, BC. Once BC is calculated, then we can find AB using AC is equal to AB plus BC. AC equal to AB plus BC. We know the total distance and we know this distance. So from these two, you can calculate AB. What will be AB? From this relationship, you know AB is AC minus BC. Using this relationship, you can get the value of AB, which is nothing but the distance moved by the student to see the picture clear. And that's what we are asked to calculate. Am I right? Okay. So I think we have done our explanation. So what I suggest is please pause the video here and try to go do this problem on your own, and on completion please come back and check your working against our solution. The solution: let A be the first position or the first location, B be the second location of the student, and D is the location of the picture. Okay, so A, this is where he was, and this is your blackboard, and this is the picture. D is a picture, and A moves, the student moves from A to B. Okay, and he says the height of picture is 1.5 meters, and the angle of elevation CAD is given as 30 degrees, and CBD is 45 degrees. Now take this triangle ACD. Okay, tan 30 is opposite by adjacent, so tan 30 will be that is CD divided by AC, but we know CD is 1.5 meters. So 1.5 divided by AC will be equal to tan 30, that is 1 by root 3, or AC will be 1.5 into root 3. Cross multiplication. Okay, AC into 1 is AC, 1.5 into root 3, we will keep it there as it is. So AC from here to here is 1.5 into root 3 meters. Okay, now take the triangle DBC. Tan 45 is opposite by adjacent, that is CD divided by BC. Okay, so but CD we know it is 1.5 meters. So 1.5 divided by BC equal to tan 45, and the value of tan 45 is 1. So 1.5 at BC equal to 1, or BC will be equal to 1.5 meters. And we know AC equal to AB plus BC. AC will be equal to AB plus BC. Right? So AC is 1.5 root 3 equal to AB plus BC, which is 1.5 meters. So AB will be equal to 1.5 root 3 minus 1.5, and you can take 1.5 commonly out. It becomes 1.5 into root 3 minus 1. And root 3 is 1.732 minus 1. So 1.732 minus 1 is 0.732. So 1.5 into 0.732 is 1.098 meters. So the student has moved from position A to position B, and the distance between A and B is 1.098 meters. Okay. So basically this is the blackboard, this is the first position, this is the second position, this is the picture, this is the first angle of elevation, he moves forward, and this is the second angle of elevation. So take two triangles, we have two triangles, ACD is one triangle, from which using tan 30 you can calculate this distance AC. Then the next triangle is BCD, and in this triangle using tan 45 you can calculate this distance. From the total distance you subtract this distance, you will get AB, that which is the distance the student had moved. Okay. So I hope I made it clear. If not, please go through this video one more time. It will become clear. Thanks for watching this video.